All right, hello everybody. As I mentioned, I'm gonna talk to you a little bit about relative motion today because it is one of the trickier concepts I think for you physics. So, relative motion is given to a term where you have something moving on something else that is moving, right? So if you're riding in a bus and you start walking towards the front or the back of the bus while the bus is moving, okay, how you move, how you how fast you're going relative to the bus is different than how fast you're going relative to the ground. So, for example, if you stand up and you start walking towards the front of the bus while the bus is moving, relative to the bus, you're walking at your walking speed. Relative to the ground, you're walking at your walking speed plus the speed of the bus. So you are just flying essentially. Most often, where this gets used is when a boat is traveling in moving water. So if you have a current and boat is moving, or in air travel, right? You are flying a plane. Pilots always have to account for the wind. So if I'm trying to get from point A to point B, okay, trying to fly in a straight line, but there's a wind, okay, if I don't account for the wind, I end up getting pushed way off. If I account for the wind and let the wind kind of push me, I end up where I'm supposed to be. Okay, so that's what relative motion is. So this is the simulation that I included yesterday in the notes, and just kind of shows how this works. So here we've got a river. So if we have a still river and we have a boat running across the river, okay, it just goes straight across. Okay? Nothing too special there. But if we add a current, okay, even though the boat is trying to go straight across, we can see that it ends up way off course, right? Because as the boat is moving forward, the current is pushing it. Okay? And because these things are perpendicular to each other, they're independent of each other. So the boat is traveling forward as normal. Okay? It's not changing direction. It's not doing anything. It's just traveling straight. But because it's in something that's moving, the end result is that it moves at an angle. So the boat with respect to the river and the river with respect to the earth. So that's how fast the boat moves on still water, the boat with respect to the river. The river with respect to the earth is how fast the current is moving. And the end result you get is the boat with respect to the earth. Okay? So, right, if I want to get straight across the river in a current, right, if I just shoot straight across, that's not going to work. Okay? In order to get straight across the river, I'm going to have to turn into the current and let the current kind of push me back, right? So you can see here, I can change the angle of launch, and you can see how the vectors shift, right? The river is always the same, and the angle of the boat is changing, and you can see I'm kind of looking for a vector that gets my boat straight across. And see now I'm turned into the river, I'm pointing into the current, but my end result, because the current is pushing back, is that I get straight across from where I'm trying to go. Okay? So that's what we're looking at and kind of what we're talking about when we're looking at relative motion.